Hey guys, today we will be doing Learning Target 6, which is about using limits to determine where a function is continuous or discontinuous. So we're given a graph with a function f of x on it, and we need to list the x value of each discontinuity and note which condition of that continuity fails. And if multiple conditions fail, we only need to put one down, but we'll talk about all of them in this video. So in class, we talked about a continuity checklist. And there are three conditions that must hold for a certain point to be continuous. The first is that f of a is defined. And a here, the reason we use a instead of x is because a is at a specific point. Next, we need that the limit as x approaches a of the function x exists. And then third, the limit of as x approaches a of the function f of x, we need this to be equal to f of a. That basically combines those first two rules and says that the limit as the function approaches a is equal to that function value at a, which makes sense intuitively, but it's good to know for this continuity checklist. So let's look at this graph and let's go left to right. So I'm going along this graph and I get to here. This is what we call a jump discontinuity. So I'm going to mark that down on my chart here. X is equal to -2 as a discontinuity. And let's look at our conditions here. Starting at number 1, f of a is defined. So I have a point here, a closed circle, and it's defined. So that part's good. Now let's look at condition 2. The limit as x approaches a of f of x exists. And this is the one that gets us here, because from the left, we are approaching a value of 1. And from the right, we are approaching a value of 2. So that limit does not exist. So we can just write limit as x approaches -2 of f of x does not exist. That's condition 2. Now let's go back to our graph and then keep going along. Oh, there's a hole there. That's what we call a hole, just an open circle. So next discontinuity is at x equal to 0. Let's go through our chart. So starting at number 1 is f of a defined. The answer to this is no, it's not defined. There's no closed circle anywhere, so when we are at x equals 0, there's no corresponding point because that's a hole there. So we have that f of 0 dne. And that is condition 1. It relates to condition 1. Okay, let's keep going. Oh, I don't need a ruler. Let's keep going down this graph. Okay, I have another hole here. So let's go through our conditions. Is f of a defined? Yes, it is, right here. When x is equal to 3, y is equal to 1. And then let's look at the limit as x approaches a. Does the limit exist? I go from the left and I approach -1. I come from the right and I approach -1. So that limit exists. That's fine. These two are fine. And finally, does the limit as f of x, or as x approaches a, does that equal f of a? So we found earlier that the limit as x approaches a of f of x, or sorry, let me rewrite that. The limit as x approaches 3, f of x equal to f of 3, that limit is equal to -1. This function is equal to 1. These are not equal. So that's that condition right there. So at the x value of 3, we have that the limit as x approaches 3 of f of x does not equal f of 3. That relates to condition 3. So I hope this makes good sense. Definitely good to have that continuity checklist memorized or just a really good understanding of it, because we test your knowledge first that there's a discontinuity and also recognizing exactly what that discontinuity is. But yeah, if you have any more questions about this, stop by office hours. Thank you.